Should we make a start then? 5 minutes past. Let's make a start.
Okay.
So yeah.
So I have few things I want to say. First of all, everybody Rich gave my introduction really well. This is my second project, you can say, with Omdena, with Rich. So the first one we did it together, and we kind of like took the lead role, and that's how we kind of like came up with the strategy that what we are doing right now, that we are dividing into teams and giving responsibilities to different leads, co-leads, because we experienced that it was a very, very good learning experience for us in terms of leadership skills. Because yes, we were very good machine learning practitioner. We knew what to do. We both were able to complete the project very quickly. The first one that we started, we both were kind of like competing with each other. And in our first meeting, we technically was able to do everything until the model development phase. So technically, in fact, Rich also created some models as well in the first week. So, and then we thought that since we can finish the project really well, since we have a lot of time, so let's extend it and let's break it down and let's make it into a tutorial kind of a thing for beginners. So what we did is we basically started giving theoretical explanations and supporting it with our code. And that kind of like the feedback that we got from a lot of people who were beginners, they enjoyed it and they learned from it. And we thought that we should do this particular project exactly the same way. So far, I haven't done any of the tutorials or workshops with you, but I'm planning to do something tomorrow and Monday. So 2 next days. Anybody who is a beginner, so I will put in the link on the Slack channel. Anybody who wants to join in, please join in. What I would be doing, it would be totally beginner focused, which means all the ones who are a bit experienced, they know what to do and they have been doing all those things. But the beginners, I have received a lot of messages from several beginners that they are kind of like a bit lost and they wanted to go a bit slow or things like that. So what I'm going to do, I will be taking care of that. So anybody who is a beginner, for them, what I'm going to do, I will pick up the same data set and I will break down the basic things, how to get started with the project. First thing. What I'm going to do tomorrow is how to get started, the pre-processing part. How, whenever you get a data, what are the first important steps that you repeat on every project? For example, like looking at the heads and tails, looking at the missing values, looking at the basic description, descriptive statistics, and dealing with the missing values and those kind of things. Excuse me. So that is what I would be doing tomorrow. So I would share, most probably the timing would be pretty much same. This meeting is starting whatever time. So I don't know what time zone you are in. So whatever time this meeting is starting, I'm planning to do a meeting tomorrow at the same time. And that meeting can go on for more than 1 hour, depending on how quickly we can finish, how many questions I have, and things like that. So I will be doing code alongs, and anybody who is a beginner, I would recommend you to kind of like join me. And if you are not able to join because of the time conflicts or any other commitments, it would be recorded and we would be putting it on YouTube channel. So anybody can watch it. So the idea is to break down the whole project into tutorial-based scenarios for beginners. So I would be doing first pre-processing, then EDA, and EDA has a lot of things that are going on. You need to do kind of like univariate analysis. You need to do multivariate analysis. And since we have a lot of variables, that univariate and multivariate is gonna get so big. And then how to deal with the encoding, different types of encoding. I will be breaking it down. How to do it, what is the background theory about it, and which one should we prefer in that particular situation, we will be talking about it. Similarly, when we get to the imputation techniques, so I will not just do one imputation or 2 different types of imputation. For example, I see in the chat, some people talked about that KNN imputer is a good one. They read it on internet that it is better than the simple imputer, but they don't know why. So I will be breaking down the big background mathematics, how can an imputer works technically. Okay, so that because what I feel is when you are doing a project, as you come along a particular technique, that is the time to learn that technique to the fullest. So because just reading or taking a complete course on statistics separately and doing a project separately does not go well together. So learning statistics when you are coming across that particular topic in your project is the best time to do, because then you will be learning about it and applying it. So which means you would learn way better than learning the theory separately and applying it separately. So that is the whole point. So I will be breaking down the theoretical part, giving you simple, easy to break down mathematics and what exactly is running behind the screen or behind the code. And then you would be able to understand why this is a better technique. Okay, so that is what I would be doing, and I would be doing it for the whole project. So in this particular data set, I would be breaking it down in a way that I can make a regression kind of a project and a classification project out of this data set. So I would be using the same data set and breaking it down into a regression problem and a classification problem, because I want to show you the complete end-to-end project, whether it is a regression problem or a classification, because when it comes to the model part, I want to break it down, the regression, how to do regression and how to do classification, and what are the differences, what are the different models. So in our last project, we tried so many different models, and I will try to break down as many models as possible for regression and for classification. So when I introduced, when I was putting it on my LinkedIn that it is an end-to-end project. So this will be an end-to-end project. Obviously, those who are experienced, they are doing it and they're doing a really good job, amazing job. So far, me and Rich are enjoying that communication that is happening and the initiative that everybody's taking. So which means those who are good with that, they are doing an amazing job. But for beginners, that is my strategy, and that is what me and Rich talked about it. So I would be doing that. So I was not able to do it previously because of my other commitments, but now most probably every weekend, every Sunday, I would be doing that. And most probably during the week, I would be recording a lesson. I would be putting it on YouTube and you can watch it. And on Sunday, we can talk about, it's kind of like you can say an office hour on Sunday, which means I would put a video and you have to watch the video. And during Sunday, we can talk about it. I can go through the complete coding process, the theoretical process. Any questions you have, you can ask. Okay, so that is my strategy. You will see the link. I would share it on Slack for tomorrow's meeting. Most probably it would be starting at the same time as today's meeting is starting at. For me, it is 9 a.m. in the morning. I don't know what time it is on your end. So I think that's it. So feel free to send your messages or tell me what exactly you are struggling with, so that I can take note of those things. And when I come across those techniques at a particular stage during my explanation, I can address those questions. So thank you so much, everyone. And back to you, Rich.
Yeah, spot on. That's perfect. And I'd just like to reiterate what Salman said. If you do a course on statistics and do a course on machine learning without those statistics, it's very hard to sort of connect the dots. So as Salman said, rather than just sitting there and reading books about it, if you can actually code along with Salman, you will understand not only the statistics, but the intuition behind how the machine learning model or whatever the stage is works as well. And that makes understanding very, very easier to pick up. I was never a mathematical wizard by any stretch of the imagination. So, I done the mistake of trying to learn statistics before I went to the machine learning models, but I found the models explain it intuitively. And as long as you understand what's going on when you sort of edit some of the parameters, you will understand how that is affecting your data and what it means for the outputs and whatnot. So I would, feel like you don't know enough, or you feel like you've fallen behind in this project, Salmon sessions will bring you right up to speed and make you a lot more confident for the next couple of stages in the project. So yeah, I fully recommend, if you're able to make them, make them. If you're not, watch them, the recordings back, and code along with them as well. So yeah, thanks very much for that, Salmon. Okay, the purpose of this meeting was to basically talk about the work that's been done to our data sets. The lead for this particular process, the data engineer, was Vivek, and he was supported by Jay and Oasis as well. So I've allowed the screen to be shared. You can share your screen now. So Vivek, would you mind sharing your screen and talking everyone through the sort of decisions you made within the notebooks you've uploaded onto GitHub? Is that okay?
Yeah, can you hear me?
Yep, we can hear you. I'll go on mute and turn my camera off just for the bandwidth's sake, because it can be a bit strange sometimes. So
Okay, now share my screen.
So go ahead, you can share your screen.
Can you guys see it?
Yep.
Okay, so the first thing I did was the time feature, which just had different timestamps. I changed it into 5 different categories because I thought maybe people riding late at night might be drunk and so on, and that might be a useful feature. So that's what happens over here. And then I dropped the date feature too, because I mean I thought it's probably useless, the date, like regardless of which date is the same thing, and we anyway have the weekdays as a separate feature. And then yeah, the next thing I did was so the missing values in this, you have a lot of these none, unallocated and so on, and those are basically nans, and like the is null functions and so on, they don't detect those as null values. So I took all of those and changed them to 9, np.9, just to make it easier to analyze. So the next thing I did was I found the percentage of values that were missing in every feature, and once you do this, if you look at this feature, carriageway hazards, more than 98% of the values are missing there. So I think for the guys in feature engineering and so on, it might be a good idea to just drop that, because no matter how good your imputation is, almost all the values are missing. And you can see that over here. So carriageway hazards, 98% is missing. And then there's another one with second road class. Again, 81% of the values are missing. For at least for those two, you might want to look into whether you really need those two features. And then yeah, so this calls to fill is basically just the features that have more than 1% missing. Those are the only ones for which I impute, and for everything else I just remove the rows, because hardly any rows are missing, less than 1%. So you zero down on these 8 features for which more than 1% of the values are missing. So over here, for everything that's not in this list over here, I remove the rows. That's what I did over here with subset and accident data. You lose 10,000 rows out of 1.4 million by doing that, so it hardly makes a difference. And then another thing I do is, for each and every feature, I add another column that tells you whether or not that sample is missing. So I can show you over here, like.
Hi Vivek, is it possible if you can speak a bit louder, because some people are not able to hear you?
Okay, I'm actually speaking here. Okay, I'll try to speak louder. Yeah, can you hear me now?
Thank you.
Can you guys hear me now?
Yeah, we can hear you. It's just a little low.
Okay. Yes, little low.
Yeah, so you can see over here, there's the first road class missing, second road class missing, and so on. This is just to say if this is false, then the first road class, this is not a missing value. If it's true, then it is a missing value. The model might pick up on that, so it's a good idea to try with and without these features, these last 8 features over here. Yeah, and then finally over here is the imputer itself. The strategy for the numerical values is mean, and for the categorical values is the most frequent. So whichever one is most frequent will be replaced with the missing values. And then once you've done your imputation, so if you remember this second role class, it had 80% missing values. So after imputation, you can see this distribution changes completely. C, B, and motorway and so on are almost negligible in comparison because you replace with your most frequent value and almost everything goes over here. And this is where the iterative imputers and the other LGBM imputer is way better. The one numerical feature that we had hardly makes a difference because only 1% were missing. So the distribution doesn't change at all. And like I said, in carriageway hazards, it completely messes up the distribution. So I really think we should remove this. Yeah. And everything else is quite normal. Junction control is okay. Yeah. And then the other notebooks, there's one notebook for iterative imputer, another notebook for LGBM imputer. The pipeline is the same, only the imputer itself is different. So do you guys want me to run through that as well, or is this everything else is the same, only the imputer is different?
Yeah, is there much in terms of you've just mentioned the second role class distribution? Obviously, it's really because there was a lot of
for example,
yeah.
the second class, if you look at the distribution after imputation for iterative imputer or LGBM imputer, it's a lot more similar to the distribution before the imputation.
Yeah. Okay. Yeah, I see. Yeah, but that's there was a significant amount of missing values in the second role class, which was unusual because the second role class number wasn't as bad. There was only I think there was less than 1% missing on that one. So that is quite an interesting observation. But as you say, if it messes the distribution up, it's going to make a little bit of difficulty for the model as is. So it'd be interesting to see whether, as you recommend, it might be a good idea to drop them particular features and just focus on the number, the role class number maybe, because that would be inherently linked to the second role class, because they are numbered slightly differently. So yeah, that might be, that's a good observation. But yeah, as you say, the distribution there, it's not going to be very good because it's pretty much guessing at this point of what that role class is supposed to be. So yeah, that's a good observation. So each pipeline, as you say, is exactly the same. The only difference in technique has been the imputation. Has there been any sort of drastic changes in terms of distribution not of the second role class, but the other sort of categories? Has any sort of imputation made a significant difference to the distributions of them? I mean, you can feel free to show us. Just is there anything worth noting?
Yeah. So for especially for these two, where there were a lot of missing values, there's a big improvement in the iterative imputer. And everything else, the distribution remains somewhat similar. If you look at it over here, first row class, before and after, and so on. But those two, it does matter. I think you should probably try with iterative imputer first, building the models, and if that doesn't work, just remove those two features.
Cool. Okay, that's great stuff. And have you produced the data sets yet, or do you need to run these notebooks to output the data?
Yeah, I just have some cleaning to do. I'll post it tonight on GitHub or something.
Perfect. Because what we'll do in terms of the pipelines, if you're able to upload the data sets that are produced from each of your notebooks, I would recommend saving them in a Parquet file. Just so it's just so they're quite small, and I will hope if they're small enough, I'll put them on the GitHub. If not, I'll upload them to the Google Drive. You should be able to access the Google Drive and upload them into the data. So if you're able to do that, that's absolutely fine. If not, I can sort that out. That's not a problem. But you should have access to do that on the Google Drive, no problem. So that's great. Has anyone got any questions at all for Vivek about some of the decisions he's made, or about any of the code or observations that he's made? Pop them in the chat, or feel free to jump on microphone. must have explained it very well, Vivek. Just a question has popped into the chat. The notebook will be shared later. Yep, they're already on the GitHub repos, and I'd like to access the notebook from Git to Colab. Is there a way to download from Git and upload to Colab? Yes, there's a number of ways. You could fork the repository that we have on the on GitHub, or you can download the raw file from GitHub directly and save it as a IPY. I can never remember that, IPYNB file, and upload it then into Google Colab.
Rich, I can show it right away. Means it would.
Oh yeah, go on. Oh yeah, go on.
So Vivek, if you would just give me the screen.
Oh
please.
yeah.
Thanks very much for that, Vivek.
Yeah.
Excellent work.
Yeah, that was amazing. Yeah. So let me share my screen. Okay, so how to do it is pretty simple. You go to GitHub, any of it. So I'm gonna go to any of this. So this is the first one came up. So I would just go to any of the notebook. So whichever notebook you want to open up, you just open it up, go to the raw. And when you go to the raw, you right click on it, save it as whatever. It is a text file or whatever, just save it. So I'm going to save it on my desktop. When I save it, that's the first thing I did. So now it is being downloaded. Now you go to Google Colab, and in the Google Colab, so let me open it up from the scratch so that you can follow. So Google Colab, when I open it, it's going to ask you, do you want to upload or something? So I will upload. So I will go to upload and I will choose a file. And over here, this is my text file was, wait a minute.
You'd have to change the file name and on the bottom right to text. That's the one.
Oh, okay.
Yeah, the file setting, yeah.
So maybe I'll just go to my desktop and I will change the text file. So this is my text file. So I will just rename it and .ipynb. So you do that. I think I would just give it the name A, and then I will go here. I don't know, what did I open? Choose a file. And so let's go to all files. This is my file. I'm going to open it. And here's your file. So even if it is a text file, when you go to the upload page, if it is picking up only IPYNB, even if it is in a text format, it's going to pick it up. So you just select all files and select whichever file you have, because it has the code in the background and it's going to open up and you can use it on your Colab. So that's pretty straightforward.
Cool. Thank you very much. There was always, you've done some good work as well. You uploaded your notebook. Would you be okay to just go through a couple of features in your pipeline?
Yes, sure. Hi everyone. Let me share my screen. Can you guys see my screen?
Yep.
Yeah. So here I've just loaded the data frame, and then I've split it into train and test data frame, two separate data frame. And here I have dropped the time column, as Vivek has mentioned. I was having issue dealing it in the feature processing state. So for now, I just decided to drop it. And and in the test, from the test data set, I also dropped the accident severity column, because we don't have to include it in the test data frame. And here I am categorical columns are imputed with the most frequent value of that column, and numerical columns are imputed with the mean value of the column. So this is just a class or with a function. So here I am passing the train dataset and the test, both of these dataset to this class to impute them. And after that, I check for the null values. So there are 0 null values in both of the data frames. And this is how it looks like after imputing them. So here you can see the nan value in the categorical frame. So it is replaced by the most frequent. I guess the most frequent is A. So it is displaying A here. And similarly here, the nan values. So they are replaced by the most frequent. Then I've separated the categorical and numerical the columns. So these are the categorical columns and these are the numerical columns. So for both the data frames, for train and test data frame. So the reason I separated them because I was going to apply encoder on these columns. So yeah, so here I am using ordinal encoder to encode my categorical data frames, and this is how it looks like after after ordinal encoder. And the same I do for the test data frame. And the end, these are only the categorical data frame. So at the end, I joined them back together with the numerical data frame, so we can have them all in the same data frame. So this is the training. Sorry, this is the training data frame. It has the, and I have also merged back the accident severity data frame to column to the training data frame. So it has the accident severity column included, and this is the test data frame. So it has no accident severity. And then I have saved them both into separate files, training and testing data frames. So it is pretty straightforward, but I was having a lot of trouble doing the feature processing. So this is all I could do for now.
No, that's good. I mean, yeah, you've asked a couple of questions to me about, various different techniques and whatnot. But there's an interesting observation when you've used the ordinal encoder. As you can see, it's replaced the titles of the features with the index. Do you have any ideas how you'd get around that?
What can you repeat?
Yeah. So you've loaded the training data frame into the ordinal encoder, and if you take a look at the output, the feature names of the column names have been changed into the index.
Yes. Yeah. So I am going to bring these back into its original names of the columns. Yes.
Yeah. There's a couple of techniques you can do. Have you researched into how to do that yet, or have you had any ideas of how you would attempt that?
I've seen it in a couple of articles on, and I know how to do it, but I was running out on time, so I just left it like. But I will update this file until tonight. So yeah.
Yeah. Oh, that's cool. Was there any reasoning behind choosing the ordinal encoder?
Not really. I was able to implement can and imputer as well, but ordinal, yeah. So the ordinal encoder, I just out of the other methods for encoding, I thought ordinal encoding would be the most reliable for now. But like I said, I was short on time, so I can update. I will be updating this file in the coming days.
Yeah. No, that's cool. That's cool. You've done some good work there. Salman, have you got any comments about it at all?
Yep. This is good work, and I had the same question. So yes, you are doing ordinal. Since Rich has already asked you that, one thing when we are doing this encoding, everybody needs to keep in mind what kind of encoding a particular encoder is going to do. So ordinal is telling you that, which means it is picking up. So for example, like it is giving 0 value to one of the class, 1 value to other class. That means any class which is getting the value 12 is getting more weightage in your machine learning model as compared to the class which is getting the value 0. So when you do the ordinal encoding, that means you are kind of like, so ordinal encoding is usually recommended when there is an order. For example, like there are categories like small, large, very large, or something like that. Then you would do ordinal. But I don't know whether in this, because I haven't gone through the data as well right now. I don't know what kind of a variable that is. So we need to keep that in mind. Is there any order in the categories or not? If there is not, ordinal encoding is not a good choice. So we have to be very careful about our choices of which encoding can be reasonable in a particular situation. So it's just my way of thinking, and I want everybody to think. So whenever you're applying a particular technique and you don't know what exactly it is doing and which one should you apply, that is where the research you should be doing. You should be researching about what are the differences technically, which one should be used in what situation. I would recommend you to research about that. Okay, I will break it down when we will be doing our thing. I will be breaking down several different encoding techniques and explaining which one to use when and for what variable we can use what. But anyone who is doing their research, I would recommend you, this is the time. So when you get to the encoding and you don't know about it, that means that is where you can do a lot of learning, and you can learn about different techniques. Even if you don't understand how they're working, at least learn about which one to use in which situations.
Yes. So yes, sir. I knew about how ordinal encoder works. Like it assigns a different unique integer to every class of that column, but I did not know its impact on the machine learning model. So yeah, that's something that I should be taking care of here. Thank you, sir.
So
Yeah,
over here, maybe you can try one hot encoding or something, because usually one hot does not give preference, because one hot changes one. So it's kind of like creates several different columns, but yes, it increases the size of the data, your kind of like features, but it gives equal weightage to every single feature. So yeah. Because you know that in a machine learning model, machine only learns numbers, and big number means more value, less small number means less importance. So that's when you use ordinal, that means it's gonna consider big numbers as more weightage, small numbers as less weightage.
Okay, sir. Okay, sir. Thank you for pointing there.
Yeah, and you know, with the one hot encoding as well, you as someone's mentioned in chat, Manisha, and Salman mentioned it, cursive dimensionality increases your data set massively, but also you have the dummy variable trap as well, which is something to research when you're one hot encoding. As I say, there's a number of different encodings, but rather than just using one that you're shown in a tutorial, whatnot, research the different ways it's going to affect your data set and make a decision based on that. There are if your features have different weightings due to an ordinal encoder, there are ways you can sort of deal with it in the feature engineering, scaling and whatnot, but it's probably easier to make sure those sort of things don't slip into the data at the encoding period, if you know what I mean, just to save a lot of work in the future, so you don't have to go back on yourself, if you know what I mean. There's a number of different ways. So yeah, as Salman says, don't research everything in one hit. Do it step by step. You get to the encoding part, figure out what are the most common 5 encoders and how they affect the data set, and what are the pros and cons of each one, and then applying them from there. Just experiment. The only way to learn in this sort of industry is experiment and see what happens, and how it affects your distributions, how it affects your dimensionality and whatnot. But yeah, absolutely, using ordinal code, and I can see why you've done that. You would have to map into the titles back as well, but it's something, the scale of those figures that it produces for the features, you do have to take that into account, because there are a number of algorithms, as Salman has said, that do take the value of the number into consideration when putting feature importance on that particular feature.
Yes, sir. Okay, sir. I will try using different encoders and compare them in the coming days.
Yeah, but go on, Salman.
Sorry, Rich. And always don't take this as negative. We are giving you feedback. Because you are doing an amazing job, and means we are just sharing our experience that how you can take this situation and learn something out of it. So it's just that. So don't take it negatively. Our feedback is constructive, and we are not pointing out anything wrong here. So we are just telling you that you can improve on it. Okay, so don't take it negatively.
Yes, sir. Yes, sir.
We've got 10
Yes, sir.
seconds
Okay.
left, so we'll have to refresh the meeting, and everyone will have to rejoin. I'll see it in a couple of moments. Okay, we'll just give it a minute just for everyone to refresh.
And also, Rich, at the end, I would recommend we should take a picture, group picture, for putting out on Omdena Liverpool chapter page.
Absolutely.
So because we need marketing as well, and it's good for everyone as well, because if they are showing up their faces and we can tag them, and this is a good way, because doing the work, and if you're not bragging about it, nobody knows what you are doing. So I would recommend everyone to brag about it on LinkedIn, because write a post, whatever you did, share your notebook over there, and make a post about it. Tag Omdena Liverpool chapter. If you want to leverage our network, just tag each other who is working, me, Rich, or anyone, so that you can take leverage of the whole network of all the people, and get more visibility on your LinkedIn. Because the goal, I think everybody is working towards, they want to get into this field, get an industry job. So you want more visibility, and how you can get it, brag about it. So go on LinkedIn, tag any of the people. Feel free to tag me, Rich, or anyone, and brag about whatever you have done.
Yeah, Vivek, you've got your hand raised.
Yeah, so I just had a question about that ordinal encoding. So, I mean, we'll probably be building tree-based models like boosting over here because structured data. So isn't it better to go with ordinal encoding? Won't it underfit with one-hot encoding because you have too many features?
Yeah, definitely. One-hot encoding on a large number of if it creates if you've got a large data set and you one-hot encode it, you're gonna, create a lot more features. And when you use a tree-based model on a massive sort of data set, your feature space, just explodes.
Yeah, exactly.
So it gives a low accuracy compared to ordinal encoding. So yeah, if we were to take Oasis data set forward, a tree model would be best on that particular data because he's ordinal encoded it. If he one-hot encoded it, we'd have to, use something else because it would, as I said, explode the feature space, and it would seriously underfit. But yeah, it's a good point. It's a good point. But this is the sort of thinking that we need. It's like, you're going to use a particular technique at this moment in time, but you have to think ahead. How is this going to affect any sort of model building? And that is where the feature engineering team come in. They're going to make this, they're going to take your great work and make it into a data set that can be fed into a model, and the model will find it delicious, basically. That is what we get from the feature engineering. But yeah, definitely a valid point to raise. Thank you very much. Let me just check that chat.
I had
Sorry.
another question.
Oh yeah, go on.
Yeah, I had another question about like in his notebook, after he imputed, he still had those classes like none and not allocated and all that. So I mean, it looks at that as separate classes. So after he ordinal encodes, those become separate classes. Like that becomes a number, like 1 or 2 and so on. The different types of like things like none, unallocated and so on. So he should. I mean, I just wanted to say it's better to get rid of those before.
Yeah, that is a good point, actually. Definitely, yeah. But that is something. I mean, Salman's lesson will be going through that kind of thing anyway tomorrow, and it would be a good idea to talk about that, definitely. But yeah, it's a good point raised. Good point raised. Could you explain again what the issue with ordinal encoding? And that was from Joel. Joel, so when you ordinal encode something, if you've got, say, 12 features your ordinal encoder will number them features 1 to 12. Now, some machine learning models will see those numbers as being sort of weights of how important that particular categorical variable is. So it'll create a lot of bias. It'll see the number 12 as the highest of them, so it would automatically assume that that particular category is more meaningful. So it will skew the prediction, its predictive power basically. We can overcome that in a number of different ways. The first way is using a difference encoding altogether. The second sort of way around that is scaling your feature after you've encoded it. Normalizing the feature as well is also another option, but needs a little bit more a little more analysis and research into investigation basically. So yeah, does that answer your question? Do you understand why ordinal encoding is something to watch? Cool, thanks very much. Has anyone else got any more questions about what they've seen so far, or any questions about the next phase, the EDA phase at all? No, that's cool. Salman, have you got anything else?
No, just take a group picture, I think.
Yep, she will have to take a group picture, and we'll get it on LinkedIn. We'll tag everyone in it. So please, if you can, and if you don't mind, jump on the camera and we'll take a nice screenshot, and we'll tag everyone in. As Salman said, part of machine learning it's a fast-moving industry, and the best way to learn is from other people. So if we'll take this photo, we'll tag it in on LinkedIn, share it, tag everyone else, build a community, build a community of like-minded people, because that's the best way to learn. So, okay, we've got loads of people on the camera. Let me just go full screen to make sure no one is left out. I think I can capture everyone. Where is my snippet? Give me 1 second. Okay, make it full screen. I talk to myself a lot when I'm doing these kind of things. You'll have to get used to that. Okay, right, I'm going to take a screenshot. So if everyone could give the best smile, and we will tag it on LinkedIn. 3, 2, 1, go. Sorry, spot on. Thank you very much. That is perfect. You can turn your cameras off now if you want. Thank you very much for that. So yeah, so let me just talk a little bit about the next stages. Vivek is going to create some data sets with the work he's done, and we're going to have 4 data sets. 3 of them are going to be with the accident data, and 1 is the vehicle data. Each data set has the same pipeline. It's just that the imputation is being changed on each pipeline. So it will have a slightly different distribution on the features, probably not recognizable, to be honest with you. But Vivek has raised a couple of interesting points around the distribution, around some of the columns. So the feature engineering stage, that's where they're going to pick that up. For the EDA stages, we're going to deep dive. I know a lot of people have already done some high level analysis by using the Pandas profiler and the SweetViz and whatnot. This EDA phase is going to be a lot more in depth. We're going to, it's going to be a lot of it is going to be manual. And Salman can also help with the sort of coding aspect of that. I shared a fantastic resource to the knowledge sharing channel, and funnily enough, I happened across it by researching on something completely different. This guy has downloaded a very, very similar data set to what we have, and he's done quite an extensive EDA analysis on that data. And there's a lot of pieces of code in there that we could use on our data set. So please, if you're gonna do any sort of EDA, refer to that notebook I've shared, and try and implement it yourself. If you do implement it, please share it with the task leads of each particular pipeline, and feel free to bounce between pipelines, because each pipeline will have a slightly different angle of exploratory analysis because each of them have a different purpose. So, you know, there's going to be a number of ideas all going on at once. And if there's anything that you don't understand, straight away ask it into the question section, and the team, the leads and the co-leads and myself and Salman will try our best to answer it as quickly as possible. I never have my phone out my hand, so I will be there, you know, as soon as I can with any sort of questions. Yes, Salman's just suggested in the chat machinelearningmastery.com. That is a fantastic source, probably the best on the internet in terms of you know, understanding the total sort of machine learning pipeline. There's plenty of articles on there in the EDA. It's one of my favorites as well. You know, so please do take a look at that. And I think that is pretty much it. Oh, there's a hand raised.
Yes, I think there is a question.
Yes, I wanted to say something. Okay, so first of all, doing this analysis, before doing this analysis, do we need to add the two data set? We have two data sets. So do we need to add those, and then we have to do analysis, or shall we go in an individual path?
Yeah, so every pipeline is going to have its own individual data set. And Vivek will produce them, and he will either upload them to the GitHub if they're small enough, or the Google Drive. If not, I'll do it myself, and it should be ready either later on this evening or tomorrow morning. So it's already there, and you can make a start on the EDA processing. But yeah, it's going to be everyone's going to have their own. Each pipeline's going to have their own separate EDA process, and I imagine there will be, as I said, slightly different aspects to the analysis because each solution is different, so they're going to be looking at different aspects of that. And then the next phase then is the feature engineering based on the insights from the previous two tasks. But yeah, you know, we've done really well to get to this point. Vivek has done Vivek and the team have done absolutely fantastic work. But you know, always I put you as a machine learning engineer. You signed up for that suggestion. I said, you know, people who are relatively new to this kind of thing should go for the co-lead role. How have you found it? Have you learned anything at all over the past week or so? Have you improved any skills? Yes. Always you. Yeah. Sorry, that was I should have directed that question a bit better. Is there anything you can share? Any benefits of being a task lead that you can mention to other people, and you know, how has it made you a better machine learning engineer?
Yes, sir. Of course. So, sir, I've studied machine learning course in my university, but in the university, when we were given a project, I would just go and pick up some RAD code from Kaggle or somewhere and just pass my data frame to it and get and do the prediction. So I was not so I did not understand what's going on in the back, the mathematical process and statistics behind it. So in this project I have to go through everything, like if I'm using a certain encoder, I will go and see how it works, our imputation. So I have definitely learned a lot during this week than I have in my entire machine learning course.
Yeah, I mean it teaches as well, if you are involved in projects like this, it teaches independence as well, how to learn on your own and how to implement things, because it is hands-on. You know, I know for a fact I've got about 30 machine learning books and I've read most of them, but it doesn't stick in unless I actually you know, neck deep in data doing it myself. I can read all I want and I'll forget it, and I find it much easier if, you know, I'll read a paragraph and then just explore it myself and connect the dots using my own research. And when I do get stuck, asking questions to people who know more, and that's how I learn. And I think, you know, you may be different. You might be someone who's lucky enough to read a book and remember everything, but I'm just not one of those people. So you know, you know, putting yourself forward and getting involved in every task. Even if you're not a co-lead, get involved in the group channel. make some suggestions, ask questions about other people's suggestions, make the mistakes, because that's the way you're going to learn. This is a safe space. There's no judgment. You know, if you've got a question, you feel it's stupid, ask it anyway. When you're learning, there's no stupid questions. So don't feel embarrassed or shy to ask something that you might think is quite basic. It's the only way you're going to learn. So yeah, the next stage is the EDA, and we're going to get the data sets ready for you, and we'll crack on with that. So please, you know, keep up the hard work. Everyone's really contributed. We've had so many suggestions that have been worthwhile, and we can see that in the work that's been produced. And you know, the fact that the task leads are learning so much, not only from other people but themselves as well. You know, getting involved it'll make you a better machine learning engineer. And if you know, so please do it. You'll see the benefits of it for years to come. A reminder: Salman is going to host a call tomorrow. And he basically retroactively is going to look at the data, and he's going to go through his own process and operate a code along. You're more than, you know, please get there. It's designed for beginners, but if you're not a beginner, go along anyway if you've got the time. You know, you might learn something new, and you know, it's just good to get involved with the teams, and you know, get to know other people on the team and learn from them as well. It's a good way to sort of, you know, to team build as well. So yeah, that's what we'll get done. There'll be an invite. Salman will be setting up the call in the Omdena Liverpool what's it called, account. I'll pass on the details over, so you'll get a notification, and it'll be posted in the meetings link as well. It'll be definitely worth going. I fully recommend it, so try not to miss it. I've got a 1-year-old son who decided not to sleep recently, so I will try and make it as best I can, but I might not be there. But you know, you're in good hands with Salman. He's phenomenal machine learning engineer, so you will learn a lot. Will be recorded. The Zoom automatically records it, and it'll be uploaded to our YouTube channel. Someone asked about the YouTube channel link earlier on. If you go to the problem statement channel, it's in the bookmarks. It's called Autodidact Scientists. It's a channel that me and Salman run, just trying to break down machine learning techniques and ideas to an audience of beginners. We might change that name on it, though. We don't think it's got a ring to it, but you know, that's another call altogether. So yeah, this weekend calls are being recorded. This one is recorded, and tomorrow will be as well. Okay, is there any other questions before we call it a day and I give you your Saturday back?
I have pasted the link for the YouTube as well in the chat. And one thing, means if you can get hand on this book, seems like it is not. So this book, Hands-on Machine Learning using Keras, TensorFlow, and Scikit-learn. This is one of the best book out there for machine learning because it covers, so chapter number 2 has a complete end-to-end project in it, which means anybody who is a beginner, just one chapter is going to give you a complete breadth of what an end-to-end project looks like with the code, and those codes work absolutely fine. So if anybody can get their hands on it, that would be amazing. I have that chapter number 2. I will share it in the Slack, just that chapter number 2, because otherwise it's not good for the author that I share the whole book. So chapter number 2, I will share it with everyone on the Slack channel. Everybody, I would recommend take a look at it. And if you have the book, amazing. If not, this book should be your go-to book because it has every single thing, every single technique discussed with the codes, not just machine learning, even deep learning as well. First 9 chapters are machine learning. The next 11 chapters are deep learning. So this book technically covers everything. Okay, so I would recommend it. And I would share chapter number 2. For now, just take a look at chapter number 2 and see how an end-to-end project looks like. And if you want to implement, do the code along with that chapter, it would be a good practice thing for you because you can pick up different code snippets from it and apply it on this project. So, and that is if you, so I would, when I would be doing my workshop tomorrow. So in that you would see, I have made code several different times. Keep one thing in mind. EDA is same for any project. As long as you have tabular data, EDA is technically same. Means once you have pre-processed the data, then the next steps, looking at the univariate analysis, multivariate analysis, and all those things, the steps are pretty much same, because how to calculate statistics is exactly same on a pre-processed data. So what we have done so far, since we have been doing it for now, we have made templates, and you just pick up that template and apply it on any tabular data. It's going to give you a complete breakdown of the univariate analysis, multivariate analysis, and everything. But we are going to show you how to make it. Okay, so I'm going to break it down my own template into small chunks. Once we are done with the whole thing, then we will put it together and everybody would have a template by the end of this project, which they can use on any project whatsoever. Okay. That's
perfect. A couple of people are asking for the book name again.
So I will share the chapter number 2. So I just wanted to show it, but it is hands-on machine learning. I would put it on Slack. Don't worry about it.
Yeah. Cool. Okay. That is it then. I will give you your Saturdays back. Thanks for everyone making the time. You've done some really impressive work, and I'm glad everyone feels inspired to learn. And I'm glad you're joining us on this project. We've completed the first stage, and now this is where it gets extremely interesting and extremely intense. So thanks, guys. I will upload this meeting to YouTube. Please, again, subscribe to the channel. Keep on top of our meetings. I will post it into the chat. If you can't make a meeting, watch the recording and catch up with everyone. It's very important that you do that. But okay, we'll leave it there then. Thanks very much, everyone. I will see you soon.